Assalamualaikum, and my name is Nurfadin Akila. So today I would like to talk about a very high temperature reactor, which is VHDR. In this video, I would like to talk about process descriptions of advanced reactor, schematic diagram of advanced reactor, component in advanced reactor and functions, and lastly, advantages and disadvantages of advanced reactor. What is VHDR? So basically, HDR is primarily dedicated to the cogenerations of electricity and hydrogen, the latter being extracted from water by using thermochemical, electrochemical, or hybrid processes. Its high outlet temperature makes it attractive and also for the chemical, oil, and iron industries. VHDR can support the efficient productions of hydrogen by thermochemical processes. So VHDR is one of the four generations reactor. For electricity generation, a helium gas turbine system can be directly set in primarily coolant loop, which is called a direct cycle, or at the lower end of the outlet temperature range. HDR can produce hydrogen from only heat and water by using thermochemical process. Current market assessments have indicated that electricity production and industrial process based on high temperature steam. So that's all for the process description. So I would like to pass to the next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Zulaika binti Abdul Halim. So for my part, I will explain about description of advanced reactor, which is a VHDR, very high temperature reactor. So GIF, which represent Gen 4 International Forum, has been leading international collaborative efforts to develop next generation nuclear energy system that can help meet the world's future energy needs for more than a decade. So Generation 4 design is less fuel, reducing waste, and follows strict safety and proliferation resistance standard. So we will go to the description of VHDR. VHDR is a helium-cooled graphite moderated reactor with a thermal neutron spectrum. So it can provide nuclear heat and electricity at core outlet temperatures up from 700 to 950 degrees Celsius, with possibility of exceeding 1 degree Celsius in the future. So using thermochemical processes such as sulfur iodine SI or hybrid sulfur processes, high temperature steam electrolysis ESE or steam reformer energy, the VHDR can produce hydrogen from only heat and water. While the original approach for VHDR at the start of the Generation 4 system focused on very high temperatures and hydrogen productions. As a result, the focus has shifted over last decade from higher outlet temperature designs to lower outlet temperature designs. So there are two mainly reactor configuration for VHDR. So the first one is pebble bed reactor and the second one is the prismatic block reactor. So even though the shape of the fuel element for the two configuration is differs, so basically the technical basis for both is the same. In order to attain high outlet temperature and the retention of fission under normal operation and accident situations.
So next is schematic diagram for advanced reactor. So the combined cycle is composed of the gas turbine and steam turbine cycles, and it can realize the cascade utilizations of high quality energy. In the combined cycle coupled with HDGR, the topping and the bottom cycles are both closed cycles. Therefore, the optimizations for cycle efficiency is to match the topping and the bottoming cycles.
Assalamualaikum and hi, today I want to share with you the component in advanced reactor and its function. Let's go. HTGR, or known as a high temperature gas cooled reactor, is a nuclear reactor that uses a graphite moderator with a on-stroke uranium full cycle. The HTGR is a type of high temperature reactor, HTR, that can conceptually have an outlet temperature of 750 degrees Celsius. Alright, let's move to turbine. Steam turbine converts the heat energy of steam into mechanical energy. The generator then converts the mechanical energy into electric power. Our highly efficient and environmental friendly power plants will contribute to the stable supply of electrical power and reduction of environmental impact. Okay, the function of compressor is to increase the pressure and corresponding saturation temperature, which is boiling point, of the refrigerant vapor to high enough level so the refrigerant can condense by rejecting its heat through the condenser. For compressor, its purpose is to pump the condensed saturated liquid water at 800 kPa, which is 170 degrees Celsius, to a high pressure of 30 MPa at the inlet to the boiler. So we move to feed water pump. Boiler feed water pumps transport water into boiler using high pressure. This boiler feed pump is built to handle extremely high water pressure to deliver the feed water into the boiler system. Generally, a boiler feed pump can handle the pressure of up to 100 bar. So let's move to derailleur. What is derailleur? Derailleur are mechanical device that remove dissolved gas from boiler feed water. Deration protect the steam system from the effect of corrosive gas. It accomplishes this by reducing the concentration of dissolved oxygen and carbon dioxide to a level where corrosion is minimized. What are the types of derailleur? There are two basic types of derailleur, the tray type and the spray type. The tray type, also called the cascade type, includes a vertical dome deration section mounted on top of a horizontal cylindrical vessel which is served as the derailleur boiler feed water storage tank. For the spray type, consists only of a horizontal or vertical cylindrical vessel which serves as both the deration section and the boiler feed water. Condensate pump. What is a condensate pump? A condensate pump is a centrifugal pump which is named after the type of fluid handle. It is used its condenser to pump out the condensate steam as water in a technical vacuum near the vapor pressure. Alright, for the condenser, in thermal power plants, the purpose of a surface condenser is to condense the exhaust steam from a steam turbine to obtain maximum efficiency and also to convert the turbine exhaust steam into pure water, referred to as steam condenser, so that it may be reused in the steam generator or boiler as boiler feed water. Alright, for HRSG, or known as recovers heat from hot gas stream, is a kind of heat exchanger that recovers heat from the exhaust gases of a gas turbine to an extreme degree. The heat is recovered in the form of steam which is served as the power source of a power generating steam turbine.
Assalamualaikum. Today I would like to talk about advantage and disadvantage of VHDR. So first of all, I would like to talk about advantage of VHDR. There are two types of advantage of VHDR. Is it the efficient of generation and efficient hydrogen or hydrogen production? Efficient power generation, it is divided to three. It is helium coolant, thorium and uranium fuel, and higher electric power efficient. Next, efficient hydrogen production. If we are to use hydrogen as energy carrier in a carbon constant world, we must produce hydrogen in a clean and efficient manner. Very high temperature reactor with supply process heat that can be used to generate high temperature required for clean hydrogen production. Next, disadvantage of VHDR. There are three types of disadvantage. It is low thermal conductivity of helium, high heat transfer performance, and operating condition. First, low thermal conductivity of helium. The high operating temperature in VHDR causes helium apparatus to be aggravated. Second, high heat transfer performance. Coolant should transfer heat efficiently. Good heat transfer performance lead to efficient heat transfer between the primary and the immediately loops. Lastly, operating condition. The operating condition of the VHDR are beyond the temperature and irradiation condition of current like water reactor. High temperature will increase the rate of chemical reaction with automatic diffusion event on the surface on the metal in the VHDR. That's all from me. Bye.